name is Kane Fontenot, MEM North America. Thanks for visiting our virtual RefComm presentation booth. Today I wanted to talk to you about our Intercon lift and turn metal seated plug valve, designed for the worst, most severe applications in the refinery. Right here is in fact one of our 10-inch Intercon valves. You can see it's built very similar to a gate valve from here up, and from here down looks more like a plug. The difference is, of course, how the valve operates. The valve itself consists of a single point operating unit, creates a lift and turn motion, and also the body and plug interior. The valve interior has a tapered plug. The plug design comes in 70, 90, and 100% port. Actually operates quite a bit differently than what you might typically understand as a plug valve, standard plug valve. Our plug, because of the applications that we are required to deal with, consist of all metal components. High temperature, high solid content, coking potential is where we spend most of our time. So the valve itself interior has to be made of product, no soft goods, things of that nature that really would not be able to withstand those harsh conditions. Because of the design being all metal, basically eliminates the possibility for us to turn the plug quarter. You could probably do it, but it wouldn't last very long, as the metal parts would grind and really create issues for itself and diminish the seating capacity. The way this valve works, excuse me, is quite a bit different. It actually, instead of turning quarter initially, the first motion of the plug is directly up. Because the plug itself is in fact tapered, it loses contact between the seating area on the plug surface and the seat in the body on both sides as the plug begins to rise. So, the plug begins to lift. You'll see my indicator right here, lift. The plug's actually elevated. Since the plug is elevated, it doesn't have any contact points with the body. At this point, the plug will begin to rotate quarter turn. And you'll notice the indicator. Now the plug is turning quarter. Now, again, notice the indicator here. It's indicating that the valve is open, but it's not what we would call seated open. The cycle isn't in fact complete as of yet. The last motion of the valve will be the plug dropping down into the seat. Now, the valve is in what we call the seated open position. It actually is essentially a straight run of pipe at this point, if in fact you have a 100% ported valve. So, the valve doesn't require or has very few actually operating components interior of the process. As the plug drops down, it actually seats off metal to metal, plug into the body. All right. Now, because we're dealing with such severe systems, coke, solids, things that might actually plug or foul the interior of the valve, you might ask, when this valve goes into the open position or the elevated position, do I actually have cavities exposed to the process? Well, you do in fact have cavities exposed to the process. What we do in this position, or in this application rather, you'll notice several different flaps on the body itself and on the bottom. In the coking applications that we deal with all the time, we typically would come in at several different locations on the body, tap these bosses, there usually is a flange, and basically insert higher pressure inert purge media. Typically that purge media would be steam, sometimes it's flush oil, whatever actually is acceptable to the process. The way we do that is we actually hook up lines into these flats and we insert purge media at a higher pressure than whatever your line pressure is. Typical example would be let's say you have 50 psi resid going through your valve. We want to go ahead and have 25 to 30, maybe 40 psi above that. So anywhere from 70 to 90 psi steam. So as the plug elevates, that steam is going to be allowed to flush into your system only while you're cycling the valve. So now the valve is cycling the other way, and your steam is purging into your system. While it's doing that, it's keeping your valve cavities clean and free to operate properly. Now, once I go all the way quarter, and the plug drops back down into the seat, this is what we call the seated close position. At this point, you need no further action. The plug itself will drop into the seat. It will shut off your process, but it'll also shut off your steam purge. So you're not constantly spilling purge media into your process. Constant purge into your process can be extremely expensive. It can also create some inefficiencies possibly in your process, cool your drums, any number of other factors come into play there. So, to my point, the steam purge itself is only expelled into the process during the cycle of the valve. Fully open, fully closed, steam is actually stagnant at that point. So, that's how the valve operates. You do have a metal-to-metal seat upstream, a metal-to-metal seat downstream. You actually do get somewhat of a positive displacement seal interior if your purge is fully pressurized and contained in the body. So essentially your purge media at 50 psi shouldn't be able to overcome a metal-to-metal seat, 70 psi steam, and then another downstream metal-to-metal seat. So this valve is fully functional as a manual valve, as you can see. It's fully capable of being automated, whether it be pneumatically, electrically, hydraulically. We've done any and all types of automation. The valve is typically used for straight on-off occasions. We do actually roll them sometimes in a relatively slow process where you're actually building some back pressure depending on your process. It just depends. So this is the valve itself and how it operates. The key part to this valve is that, again, you have very few operating or internal components that actually see process. Inside here, you only have the body. The metal seats are integral to the body itself, a plug and a stem. So from a simplicity standpoint, the valve is very, very basic. Fewer parts to have issue with, fewer parts to be foul with coke and things of that nature. Really, the crux of the valve is actually creating the lift and turn mechanism. This lift and turn is very unique, and consequently we have a very unique piece of equipment that does that. So the whole valve in and of itself is what we call the intercon valve. This mechanism right here, from here up, is what we call the Inomat. Our Inomat device is actually what creates that lift, turn, and reseat downward motion. So I'd like to go into that a little bit more in detail. Okay guys, this is our Inomat model. It's basically a duplicate of what you find over there on our intercon valve that I was just showing to you. This is the key to the product. It actually creates the lift and turn motion that I described previously. Typically in the past, there have been other products that actually manufactured that were created to lift and turn and drop the plug. Those items were very prone to wear and tear, extremely vulnerable to pressure differentials. Torque issues were constantly a problem. Our Inomat design took all those things into account, and this is what we came up with. The Inomat device has been around for quite some time. it's utilized on our own equipment, but it actually is also fully capable of being retrofitted onto other designs or other lift and turn plug valve designs. So we've done many of these in the field and in the shop on the fly. So with that, I'd like to give you a little bit of an idea of how this thing operates. The Inomat itself is a 3-cylinder operating unit. And of course, this is a cutaway, so the interior is exposed. Typically, it would be fully encased in a sleeve and sealed, so none of this area would be fouled by coke or dust in the atmosphere. The 3 cylinders themselves, they consist of what we call a stem cylinder, which would be connected obviously to the stem right here, stem of the valve, and this is connected to the axle right here. Sometimes people call it the axle cylinder. The secondary cylinder is the one that has this groove on the interior. We call that our gear cylinder because it connects to the gear head. Our third cylinder is this exterior piece that's got a groove in it. You can kind of know it's a split body unit combined together. And we call that our stroke limiter or our guide cylinder. These 3 units create the lift and turn motion. So, the way it works, basically, we have the gear cylinder on the interior. It has a groove in it that I mentioned to you previously, and an axle or stem cylinder. What we do, we call it the gear cylinder obviously because it's connected to the gear. As we rotate the gear head, the groove on the interior of the unit has a ramp. As that ramp passes underneath the axle, it creates lift. So we're forcing the axle up via the groove. Once the axle is fully elevated, and of course again remember that the stem on the axle cylinder or the stem cylinder is connected to the stem of the valve. The plug is actually elevated at that point and is non-contacting the plug and body seat. Once it's fully elevated, the angle will come across and actually create the quarter turn motion. You can see the axle sliding through the guide cylinder. Once the axle has contacted the guide cylinder on the other side, can no longer go quarter, the top portion of the groove now will pass across the top of the axle and create the downward motion. And obviously as this downward motion goes, the plug will be pushed further down into the seat and shut your valve off. All right? Now, the Inomat device with the angles basically is designed with different angles interior of the groove such that the bottom portion of the angle here that creates the lift actually has more force output than does the top portion of the angle. Top portion of the angle is a sharper angle and actually exerts less force. It may seem counterintuitive, but basically what it amounts to is your valve, our valve, requires less force to shut the plug off in the downward motion than it does to elevate it out of the plug. So we've accounted for that interior of the groove via the geometry. So what you have is a very simple system. It's not dependent on pressure. It doesn't have issues with temperature. It's extremely rugged. We've tested it well in excess of 1,000 cycles, 2,000 cycles. We've had units in system, in cokers, in ethylene systems across the world that have had multiple thousands of cycles. So we know it operates ruggedly and is very durable. So that's how the unit operates. This, in conjunction with the quality design of the plug and seat, create a valve that is extremely reliable and should be a quality product and in good shape for you for quite some time. If you have any questions, please let us know. Thank you.